Oh, Jesus, hold on now. There you are now. You know, we'll just sit and marvel at it there for a while. Is that okay? Just anyway. It's really strange watching yourself back, by the way. Very weird. Now, so sorry, we forgot the start of the video there. Just to explain what I've already been explaining. Um, we're now doing understanding design principles, which is 2.4. And just to briefly recap again, we're going to design principles an established idea or best practices that facilitate the software design process. Okay, so an invariant, first one we're going to do is an invariant. Invariant is a property of truth that is maintained even after the data has been modified. So an example of an invariant is the age of a born human being. As soon as you're born, you have an age. Okay, so you can't have an age that's less than 0. Now, if you're just born, it's going to be an age of seconds. If you're born a couple of days, well, then you have an age of a couple of days. Born a couple of weeks, then it's weeks. Born a couple of months, then it's months. You're born more than a year, then it's a couple of years, right? So you always have an age, okay? So an invariant is to make sure that once given an age as well, so you can't give an age less than 0, all right? Can't give an age less than 0. And also, once given an age, you can't change that again to less than 0. Okay, similar to weight. Now, every physical object has a weight and a mass. Okay, every physical object has a weight and a mass. So we want to make sure that the weight of the object is not going to be minus number. Okay, or 0. There's no such thing as 0 weight. Everything has some weight. Everything has some mass. Okay, and we want to make sure that once we assign a weight, we can't change it to less than 0. Is everyone okay with that? Yes? Okay. Now, so is there a relationship? That's just simply an inheritance relationship. A dog is an animal. A cat is an animal. A flower is a plant. A plant is not a flower. Okay, it's just an inheritance relationship. Has a relationship. A bird has feathers. A bird has claws. A bird has, now they can be objects or they can be, yes, usually objects there. Object composition. That's an object that's made up solely of other objects. So you can imagine a human being is made up of a skin object, is made up of eye objects, is made up of lung objects. Okay, it's made up completely of objects. Java Bean is just a standard for writing classes, namely making your variables private and using getters and setters to access those private variables. That's all Java Bean is. Yes. It has a relationship. Internal class will be has a. It can be either. Okay. Now, you can create an object out of many objects, but doesn't necessarily have to be a part of it. Right, so a bank account is going to have human objects interacting with it, right? But you can't say a human object. You can't say a bank. I suppose I don't know. Yeah, it's a tough one, Kieran. I don't know. I don't know. I don't know. Jesus, I don't know actually. No, I don't know. That's the honest answer. Ah, that's a has a relationship. Okay. Um. So what you have something. Object composition. It's made totally of objects. So there's no variables at all in it. Oh, there is variables in it. So, well, has a relationship. Um, it can be primitive variables as well. Like they don't have to be objects. Has a relationship. Well, yeah, feathers can't exist without a bird, or a tail can't exist without a donkey. Yeah. That's probably the best way to say it. Yeah, I'll have a look at it. Yeah, but yeah, okay. Well, I'll think about that one. Right, invariant. So now we're doing invariants, right? So I'm into the human class. So we want to ensure that every human has a non-null name, okay? And we want to make sure that every human has an age greater than 0. Now, there's two ways we can enforce it. The first way we can enforce it is if we assign a name that's null, we can throw a new legal argument exception. And you can put in the catch block, you can put in code that'll, let's say if it's connecting to a database and if it connects up to a null value, all right? In the catch block of your try catch block, you would have code that searches for another value. Or you'd ask the user for another value for the name of the person. All right? So throw a new illegal argument exception, and in the catch block, have some code that assigns a name to it. Okay? Or alternatively is if you have a null value here, you can assign a placeholder name. Okay? What's a placeholder name? John Doe and Jane Doe. Then you can have code that goes through all your humans and it picks out the John Doe and the Jane Doe and it asks you to put in a replacement. Or it searches the database and everywhere it sees John Doe and Jane Doe, it puts in a replacement for it. Okay? Or it could be John Doe 1, Jane Doe 1, Jane Doe 2, John Doe 3, so on and so forth. Okay? So there's two ways around it. You can throw a new illegal argument exception, and inside the catch block you have code that either gets another name from the user or the programmer or searches a database for another name, or you can assign a default name to it and then have other code that searches for John Doe and replaces it with a real name. Yes? Does everyone understand that? Right. So we're going to show both ways of doing it. All right? Now, sure this done right. So I'm going to create a human constructor. All right? And it's going to take in a name and an age. Now, check something here that I have not done. Now, I'm not going to do anything in the human constructor quite yet. All right? Now, I'm going to create getters for, I'll say it yet. I'm going to create getters for the name and age. Okay? So I'm going to go here. Make sure that I have them right. And I'm going to make them private. Private get name. Actually, they should be public. Sorry. Public string get name. And so what do? We just return name. Okay. The other getter is public int get age. And we'll return age. Now the getters aren't the important ones in these ones. Okay, what is the important thing is the setters. All right, so that's what we're going to do here is, actually I'll just quickly create the setter. So I'll create the setter for name. So this is public void set name. It takes in string name. Okay, so inside here we're going to set the name. I have another one. And by the way, this has to be private. And the other one is going to be private void set age int age. Now, so what we're going to have here is the only way we're going to be able to set the name and set the age is by calling these methods. Yes? Okay? Now, so when I create a human and I pass it in a name, it's going to call the set age method. So I'm going to say this dot set name. Now, so what's going to happen inside here is it's going to take this variable, okay? It's going to do a series of checks inside here. If it passes those checks, if it's not null in other words, okay, it's going to assign this name to this value. Does everyone understand that? Okay, so set name. Let's try and get it all on the one page and put it up here. Right. Right. So the only way we can give a name to this person is we have to use the constructor. Right? Now, so what we're going to do is this set name. So what happens inside here is if this proves to be not null, okay, if it proves to be an actual name, an actual word, it's going to assign that name to that guy. Okay, so that's the only way we can set a name is through here. Okay, so what we need to do is inside here we need to ensure that when we are setting a name is that it's not null. Yes? Sorry? No, wouldn't. No, it does accept null. Okay. Now, so we have to find out if it's null. However, there is a string that's not null, and we still don't want it to use that string. There's one particular string it can use. If I just say check it's for not null, right? I have to check for something else as well, though. So when I say it's null, I mean, let's say name. So what I do, I send it a null. Now, there is a string as well I want to rule out. What string is it? There's a particular character I want to rule out. Exactly. Space. I want two things. I want to rule out that guy. Okay? Because that's a space. Now, how we rule out that guy is that we take the string and we trim it. Okay? If we trim something that has a space, you end up with that guy, which is a string of length 0. Okay? That is a valid string. So we want to rule out, first of all, the space. Secondly, we want to rule out a string that's got a length of 0. So what do we want to rule out? We want to rule out null. We want to rule out space. We want to rule out a blank. Yeah. We want to rule out a string of length 0. Okay, and we're going to do it in that order. We'll rule out nulls first, then we rule out spaces, then we rule out length. Now, how you basically do, you check for null first, okay, then you trim it. Okay, if you trim it and it's just a space, you're going to end up with that guy, which is a string of length 0, and then you check to see is it a string of length 0. If the string of length 0, rule it out. Okay? So, have it here. So we're going to go here. So I'm going to say, I'm going to do it all in one if statement. Okay? Now you could do it in a series of if statements, but here I'm going, because I've been doing that all along, you need to be familiar with this way of doing it as well. Okay? So this is using ORs. It's probably harder to read than a couple of if statements, but we have to get used to this way as well. So if I go, if name is null, or name dot trim. Now remember, you can chain methods of the string class. Remember that? Okay. Now when we come to the builder pattern tomorrow, we'll be creating our own chained methods. Okay. So you can chain string methods. So I'm going to trim it. Then it's going to check the length of it. So, and they're all looking in at us again. Well, I draw a little picture on the screen for them. Hold on. I'll draw a little picture. They're still looking. And they're still looking. Would you stop looking? Huh? Yeah. There it is. How are you lads? I'll give them something to look at. I should have drew something rude, maybe. Okay, so name.trim.length. Okay, so if name is null, or name.trim.length is equal to 0. Okay, so what that guy does is, as I said, if you have two spaces, okay, so if you have nothing in your string but spaces, trim will get rid of all the spaces. Okay, if you have nothing but spaces in your string, trim gets rid of all the spaces. Okay, so then you're left with the string of length 0. So if name null or name.trim.length is 0. Okay, but I'm going to show you one of two options. The first one is going to be throw, oops, sorry, and it's not, it should be that way. I'm going to say throw new legal argument exception. And a name is required or our human. Now, it is possible as well, when you have that, if you catch it in your catch block, to assign a value to it. All right? In your catch block, you can assign a value to it. Now, we're not going to be doing any more with exceptions. I'm sure you're very sad to hear, until we get to chapter 6. Sorry about that. Sorry. I know you're looking forward to it. It's actually a fairly short chapter, because there isn't an awful lot more. Sorry, no, damn it, I know. It's like chocolate dessert, isn't it? I know what you love them. Again, pigtails thing. There was another day where tying pigtails in each other's hair was lovely. Now, so what happens here is, if it's not, if the name is null, or if the length of the string after you trim it is 0, we're going to throw a new argument exception. Or, okay, so it's going to exit at that point. Yes? Does everyone understand that? Now, make sure that this is right. I'm going to put in an else, even though I don't have to. Else, I'll say this dot name is equal to name. Yeah. So if it passes those tests, I can say throw new legal argument exception. A name is required for our human. Else, this dot name is equal to name. Yes? You understand that? Now, the alternative to throw in a new legal argument exception. I don't really recommend this. I don't know why. Is we can say this dot name is equal to John Doe or Jane Doe, isn't it? And you can have other code in that scans all your names for Jane Doe and it changes them, gets them from a database, or gets them from the user. Do you understand that? So that's another way of doing it. And that's equally valid. Because it's relatively easy. If you put that into something called, if you put that into an array list, it's relatively easy to search for only Jane Doe's and to change it. It's fairly easy. Okay? Now, obviously, Jane Doe's for women, John Doe for men. But we're going to call them all Jane Doe. Is that okay with everyone? So we've got two alternatives. We can throw a new legal argument exception, or we can say this name is equal to Jane Doe. Yeah? But I'm not going to use that one. I'm going to go throw a new legal argument exception. All right? Now, so that's the set name. So we're going to do the set age now as well. So I go here. I'm going to go private void set age takes an age. So we want to make sure that the age is, sorry, I have it there ready. So private age set age. So what do we want to make sure? So if age, I'm just going to say less than 0. That's all we're checking for. So if age is less than 0, throw new legal argument exception. Age cannot be a negative number. So I'm going to say choose 0 if younger than 1 year. Now, so if the age is less than 0, do all that. Otherwise, else this dot age is equal to age. Okay? Or alternatively, instead of doing all of that, you could just come along and say this dot age is equal to 0, which isn't wrong, because we're not going to measure the age in days or whatever. Okay, if they're less than 1 year of age, we're going to say their age is 0. They can't be minus numbers. Okay, both of those are perfectly valid ways to insist on invariance. Invariance is a value that can't contravene certain rules. Okay, the age can't be less than 0. We can't have a null string, or it can't be a string of 0 length. Yes? Is that okay with everyone? Now I'm going to test it to make sure that it works. So you always test it with something that you know that will work. You always test it with something that you know won't work. And you always test it with something that may or may not. It's on the border, right? If you're really stuck for time, always test for something that you know will work. Always test for something that does not work. Always test for something that you may or may not work, okay? Now you should do a lot more tests than that, but that's the basics. So we're going to test for each one of these. So I am going to go to the examples class. And we're going to create a human. So I'm going to go, first of all, I'm going to create a human that is correct. Static void ex1. And I'm going to put each time I create this human, I'm going to put them in a try catch block. Okay? So I'm going to go try. I'm going to go human array is equal to new human, and I'm going to pass it in a value of array, and I'm going to pass it in a 5. Okay, that works. So catch exception e dot get. Now the get message thing, what does that do? That just gets the message of the exception. What's the message of the exception? That guy. A name is required for a human. Okay, or this one. Age cannot be a negative number. Choose 0 if younger than 1 year. Right? Because remember, which only one exception. Yeah, yeah. So we're going to do both. Okay. So this is fine. Okay. To prove that it works, our human. Now I have comments, but I'll just copy and paste the comments in, and you can download the code yourselves. All right, because they're long comments. Very long comments. So our human is created. So I'm going to run this one from main. So I've got examples.ex1. So our human is created. So works fine. Our human is created. If that was an exception, was generated, it would have gone down to here. So the human is created fine. Yeah? Okay. Now, I'm going to create a human that's going to have a null name. So I'm going to go human Helen is equal to new human, and I'm going to give her, pass her in null, and pass it in 34. I'm going to do the same again, catch block. A name is required for our human. Okay, so an exception is generated. This guy catches the exception, and so E is the exception object, which is a legal argument exception object, and the message of that is E.getMessage. Where does it get the message from? It gets the message from here. A name is required for our human. Okay. Oh, you mean that? No. It's expecting some object to start off with. Yeah. So, well, no, that still won't work. Okay. So we're going to try it with null first. Doesn't work. Okay. So the object is not created. Okay. So if you don't pass it in a valid value, the beauty of this is the object is not created. Yes. Okay. All right. Now, because the reason it's not created, I just need to explain that, is so I should have done this. Sorry. This dot set age. All right. So when I create the human object, I pass it in a name, I pass it in an age. Okay. So I pass in null into here. Okay. So name is null. So this dot name is null at this moment in time. Sorry, name is just null. Okay, name is null. Now, so this dot set name name. So I pass it down to this guy down here. Okay, so if name is null, it is throw new legal argument exception. A name is required for our human. All right, so our object is not created because it never gets, this line of code doesn't finish, so it doesn't get to this line. So our object is not created. Unless you provide it with valid strings, it will not create a human. Yeah? Now, valid string, I'll show you what else is not a valid string. So, we're going to create another human. So this is going to be human Harriet is equal to new human. Now I am going to pass it in that. Okay. So that is a blank. Sorry, that's a space. Okay. Now a name is required for our human. Okay. Now if I put in two spaces, four spaces. Yeah, yeah, but this way is easier. System, trying to check human with spaces created now, just to make sure the trim works. Yeah. Okay. Human with spaces created. That is fine. So human was created. First human was created up here. Okay. Second human was not created because that's a null. This human was not created because it's a space. Okay. The next human won't be created. The next human won't be created because it's a string of zero length exactly. Okay. So I'm going to say human with no length string created. A name is required for our human. Okay, so this is an invariant, and it forces you to give a name to your human. Now you can put your code in the catch block here to give the human a name. You can put the code in here to give the human a name. Now it could get it from a database. It could get it from the user. You could have a whole little GUI opening up inside there, and it says, please enter a name. Okay, so if the name is null, name trim.length, blah, 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 you put in your little GUI inside there, and the GUI appears on your screen. Please input a name. Okay, so you can put it in there, or you could put it in the catch block. Or if it's getting the value from a database, searches another database, or searches somewhere else, or does some other SQL query. So you can rectify it anywhere. Now I haven't put in any code here that gives the human a name. That's your job. Okay. You could just have a little pop-up that says, please enter a name for a human. Yeah, no, exactly, yeah. Because if you don't do that, you can have a null name. If you don't have these rules, you can have a minus something. Okay? Say that again? Inside the generic interface. So you're using an interface to give values to an object. Sorry, I was just looking at that. I need to shave. Uh, sorry about that. Say that again, Jason. Sorry, go on. Yeah. So a single get, and you can have your little these dudes, and it can take any object. Yeah. I'm trying to think now. Why wouldn't that work? Uh, yeah, actually, that probably would work. But You're still going to have to provide implementation for it though in your class. You still have lots of getters and setters in it. Yeah, but you see, you'd have to have a getter and setter for each one of the variables. Still, wouldn't you? Think about it. If you've got 20 variables inside it, you're still going to have 20 setters. Oh yeah, you can have your checks in all in one method if you want. Yeah, of course you can. Yeah, you can. Yeah, yeah, you can. And so it'll go through all the checks inside that one setter. Yeah, yeah, you can. Yeah. Nothing stopping you. Yeah, but the only thing is there, it might be harder to spot. Whereas if you've got separate setters for them, you know, right there it is. And it's also easier to get to in your code because, see them all here? Whereas if you one big method, just harder to read. Just harder to read, that's all. That's the only advantage of it. Okay, so I'm going to put in, so age. Right, so human with no length string created, that doesn't work. All right, now, so I am going to enter in a human that has a correct name but a wrong age. So I'm going to put in new human. Now, these are all local variables, well, by the way. So I can use Harriet twice. Okay, they're all local variables. So I have Harriet and I have -1. Okay. Age cannot be a negative number. Choose 0 if younger than 1 year. Okay. So you can put in 0. If I change that to 0, works. That's just the way I have it constructed. If I said greater than or equal to 0, then let's put it in here, human with minus age created. Now, if you have a human that's got both an invalid name and an invalid age, I'll show you what happens. So I'm going to put in blank and -1. Okay, so I'm going to say human with both values valid. Okay, so what's going to happen is a name is required for a human. It never gets the -1. Okay, so watch the play next door now. She was telling me she had Joe Dolan from today. All right, now what I'm going to do is I'm going to copy and paste in the comments into that code. Okay, so I have a lot of, and you can have a lot of comments. There's no use in me wasting time typing these all out. So this one, valid arguments will print out our human is created. Okay, invalid string, this one here, invalid string, this one here, invalid string, this one here, valid int, this one here only gets to invalid string. Okay, that one, human class, Copy and paste this into the human class. Constructors called the set name method, so I should put this down here. Now, so the beauty of using the set name is we can add in as complicated rules as we want inside here. It won't affect anything else. You understand that? Okay. We can put in as complex, so I'll copy and paste it in here. This is only concerned about the name. It won't, that's another thing as well, Jason. If you have all one method that does everything, you could have cross-contamination easy enough. If you have a method that looks after the name, that's it, right? Doesn't deal with anything else. Oh yeah, you could, yeah. But still you're dealing with different variables. All right, so we can add more complex rules. So you can add as complicated rules as you want inside here. You can give it a name using, I don't care, some sort of, you could check a database for available names. You could have a GUI inside here that pops up, enter in a name, any one of those things. This one here, that one? Yeah. Oh, no. I mean, if I did this, -1. No, because it's looking for a constructor that takes an int in the string. And there is no constructor that takes an int in the string. So it just doesn't compile. Hold on, I'll just change this back to -1. Now, what did you say? Oh yeah, you could, of course, yeah. Yeah. You can check both, yeah. Yeah. So you could for this one. So if the first one throws an exception, try the second one for an exception. Yeah. You can. All right. You can. If you want. There's no need to that. Because if the first one fails, it never gets the second one. So why would you bother checking the second one? Well, actually, yeah. But yeah, it probably would be useful exercise to check for the second one as well to make sure that it is a valid age. All right. So yeah, maybe it would be valid exercise. Yep, you could, yeah. Say it again now. Yeah, yeah, yeah. You could highlight them in what way? What are you talking about now? Oh yeah, well you could. By the way, you could use if they're objects, you could use a predicate to check that they're valid or invalid. Okay, so you could have something called it. You could have a class whose sole purpose to existence is to check that all the values are valid values. All right. So if you've got a big complex class, you've got a lot of variables in it, you're probably better off creating another class whose sole role is to check all the values that are valid, see if they're valid. Yeah. Yeah. Sorry. Or int. Yeah. Yeah. You can, but then in how you implement them as well, of course, though. You could lambda just implement them. You could we do assertions. We do assertions. I forget what they are now, Andrew, so don't ask me what they are. But we do them. Okay? Not doing them till after Christmas. I haven't looked at them in 2 years, so I forget what they are. Yeah. Yeah. No. But they're playing Christmas songs already. Ah, Jesus, it's too soon. That's a character. That's not a character. Okay, but it is a string. It's an empty string. So okay. Now that's invariance. Now, as I say, you can make the rules as complicated or as easy as you want. Okay. Now, of course, one very simple way to ensure that no invariants happen is this. Okay. So if um, if I pass in something that's -0, or sorry, if I pass in something that's if I pass in a name that's null, it's going to revert back to the original, which is John. If I pass in an age that's less than 0, it's going to revert back to the original, which is 0. Okay, it's another way of doing it. But you're probably better putting off in all your invariant code in the one place, which is down here. So everything is in this method is just to do with the names, and it's just to do with if it's an invalid name. All right, so you can have all your code in here. All your code to do with invalid names goes in here. Okay. Yeah, yeah. So actually, I actually haven't given it an age here. So else this age is equal to age. So if it's less than 0, it won't. So if it's less than 0, the object won't be created. If they have a null name, the object won't be created. I took it out. The reason I took it out because it's the reason I don't recommend you doing that. What you see, here's the thing. So the default here is going to be 0, right? But that doesn't take care of the problem if I'm creating a human with -20. Do you get me? So that's so yes, it is going to have a default age of 0. Okay, but it doesn't stop some gobshite coming along and saying this person is -20. Okay, so chill out for the next 10 minutes, and that's invariance done. So there's only 4 more to do in this section. So let me just see what the other 4 sections. Hold on a second now. So the other 4 sections are: is a relationship, that's easy enough. Has a relationship, that's grand too. Object composition, nothing difficult there at all. Java beans, we'll be doing it all along. Okay, so we will have all of those finished tomorrow before lunch, and then we'll get on to something that's useful that you were talking about this morning, Jason. A singleton. Well, sorry, we're going to do singletons first, then we're going to do the builder pattern, and then we're going to do the factory pattern, and also we're going to create an immutable class. Now, we've already used an immutable class string, so we're going to be creating our own immutable class. It's more difficult than you think, by the way. All right, it's not just about making the class final. You have to do a lot more than that. Okay, so chill out for the next couple of minutes, and then you can go home. Okay, so I'll load up this video. So I'll stop this. So I'll load this video. That's the reason I finished 20 past, so the videos for that we've done this evening will be loaded up. Now, don't quite go yet though. Right, T-bin. So we're starting again. So down here. It's a bit bigger. So yesterday we showed you. So we're covering invariants, which we've done, which is in the human class. That means if there's some property of a class is true, it's always going to remain true. So, for instance, an age can't be any less than 0. All right. And how we accomplish that is through a setter. All right. So we use. First aider to reception. Thank you. That's never a good call. Okay. So we're setting the age. We send an age to us. Now, the age will not be set if the number is less than 0. Okay. Aiders to reception. First aiders to reception. Thank you. That's not good. Okay. This dot set name. So the only way you can set a name is through in the constructor. Okay. So once a human is given a name, you won't be able to change it. All right. You won't be able to change it. Number one. Number two, you won't be able to give it a null name. Okay. So how we did that? We said if the name is null, or if we trim the string of all spaces, of all external spaces, if the length is 0, which is a blank string, or a string of 0 length, throw a new legal argument exception, so the human will not be created. Now, the way this is also created here, once they're given an age, you can't change the age. All right? So, if you wanted to change the age, you'd have to set up another method that would access this guy. Okay, this set name prevents you from giving a null name to a human. It also prevents you from giving a less than 0 age to a human. Okay, the object won't be created. All right, the alternative is to create the object with a generic name, for instance, Jane Doe. All right, or to give them all a generic age of 0 if you don't give them a proper age. Okay, see there? So what I chose to do here is that the human object won't be created if we give it a wrong age. The human object will be not created if we don't give it a right name. Right? So they're invariants. Something that's always true about the object, even after creating it. All right. Now, the next one we cover is, which we've done plenty of already, is a here. Hold on a second. So, is our relationship. Okay. Now, is our relationship is either an inheritance relationship or if a class implements a interface, all right, which you're all familiar with. So we'll just do a couple of them here. So I have public class employee, all right. Then I have class accountant extends employee. We have an interface called movement, and inside that we have void walk, void fly. Then we have class astronaut, extends employee, implements movement. So that means it has to implement methods. So we have a walk, so it's just going to say astronaut walking, astronaut flying. Okay. Now, this is the is our relationship. So, class astronaut extends employee implements movement. All right. Now, when a class extends a class, you say that's an is our relationship. An accountant is an employee. All right. An astronaut is an employee. That's an is-a relationship. All right. Now, when a class implements an interface, you also say that is a relationship. All right. So an employee is a movement. All right. So I'm just going to do examples in here. So I'm going to go static void ex2, and I'm going to create an employee. Edit is equal to new employee. We're going to have an accountant. Andy is equal to new accountant. We're going to have astronaut. Any is equal to new astronaut. And then we have any.fly. And any.walk. Okay, so first of all, see employee class file for all these classes. So the object Eddie is an employee. The accountant Andy is a employee and a accountant. The astronaut Annie is a astronaut and a employee. And when a class implements an interface, it is said also to be is a relationship. So astronaut is a movement. All right. So if a class implements an interface, it's also said to be an is-a relationship. An employee is an employee. It's also an object. An accountant is an accountant. Is an employee is an object. They're all is-a relationships. Yes, sorry, should that here. Andy is an employee and an accountant and an object. Okay, the astronaut Andy is an astronaut and an employee and an object. Okay, when a class implements an interface, it also said to be an is-a relationship. So astronaut is a movement. Is that okay? Nothing too difficult there at all. Right, so that's is-a relationships. Nothing to them at all, really. Okay, put that in there. Is a relationship. Okay, now as well as an is-a, there's a has-a. Okay, so that's static void ex2. I'm going to do static void ex3. So what is a has-a relationship? Has a relationship. A fish has scales. A bird has feathers. A object has a particular property or value. So if a superclass object has a public or protected attribute, then subclass also has this attribute. So it's something a object has. Okay, now I'm going to go to primate class. Okay, let's go to primate class. Now, so I'm going to put nothing in the primate class. Okay, but I'm going to go class. What do you call the small little monkeys that have got a tail? Anyone know the name of a monkey that has a tail? Not a chimpanzee, not an orangutan. Ah, jeez, do you not know your monkeys? Can't do Java anymore if you don't know your monkeys, folks. It's an intrinsic part. Let me just see. Right, so Mr. Google, let's see it. Name a monkey with a tail. No, a gorilla doesn't have a tail. Jesus, it'd be a damn big tail. Okay, let me just see. Tailless monkey. Squirrel monkey. Oh, that's too long. A howler monkey. Right? So, a macaque. So, there's a monkey called a howler. Right? Okay, class howler. Huh? Now, geez, don't you learn things in Java? You're learning about monkeys with tails. No, geez, they be. Here, the IGs now. That's it. Out. If you don't know your monkeys, out. They're vicious bastards, actually, chimps. Did you ever see the documentary Louis Theroux did about people who had chimps for pets? They've killed a rank of people. Like they're dangerous fuckers. Anyway, so monkeys. Oh yeah, well, chimps are. Huh? They're probably carjacked them. You know? All right. Now, so we're going to say a variable. So we're going to say Boolean has tail. Okay. Now, I'm not going to put anything else in there for a minute. Now we're going to have a separate class called tail. Okay. Now, so has tail, it's going to say whether this howler monkey has had a tail or not. Okay. So Boolean has tail, that's going to say whether he has a tail or not. Okay. Now we're going to have a variable called private tail my tail. Okay. So inside the howler class, I'm going to say Boolean has tail. So it has tail. If that's true, my tail is equal to new tail. Okay, so my tail, that has a relationship. Okay, it's something that's part of the howler monkey. Now it can be an object, it also can be a primitive. Okay, it doesn't have to be an object, it can be a primitive. So class howler extends primate. Now I was going to put all of this in here, up here. However, not all monkeys, not all primates have tails. For instance, we don't. Do we? Well, I thought you were going to say something else there for a minute again. That is true, yeah. Okay. But you don't see too many walking around the place with the tail sticking out from. No, that I have, unfortunately. Uh, okay, so this is a. Now I didn't put this up here because chimps do not have tails. Okay, so if I put all of this up here, that would not be a has-a relationship. Do we understand that? Okay, because not all primates have tails, but all howler monkeys do have tails. Okay, so I'm going to create another class down here, which is going to be class horse. Okay, so I'm just going to put in a comment here. This is a, so the tail attribute of the, sorry, the my tail attribute of the horse class is a, has a relationship. As all horses and subclasses of horse will have a tail. Okay, with howlers, only howlers and subclasses of howlers will have a tail. So only howlers and subclasses of howlers will have a has a relationship with my tail attribute. Okay. So there's nothing really that difficult here at all. So if I just go here, I go private tail, my tail, horse, blank constructor. Blank constructor, so I go horse, and we go my tail is equal to new tail. Should be capital T. Now I want to make sure that I have given a value to my tail. So I go void check tail. Now I'm going to just print out something. Okay, this is not an invariant. I'm just checking to make sure that my horse has a tail. So I'm going to say if my tail is null, I'm going to print off no tail, else has a tail. Okay, so it is possible to pass a null. I didn't bother to put in an invariant set tail method. Okay, you could make it invariant to make sure a horse has a tail. Okay, a horse doesn't have to have a tail, by the way, because you can cut them off. It's cruel, maybe, but yes, you do have horses without tails. Okay, so any subclass of a horse is also going to have, so class Shetland extends horse. Okay, so all subclasses of horse also has a relationship with the tail class. Now, this is just a term. It doesn't really matter for the practicalities. It's just the names of stuff. Okay? It's basic cop on. An employee is an object. An accountant is an accountant. An accountant is also an employee. An accountant is also an object. That's an is a. An accountant has a name. An accountant has an age. An accountant has a house. Okay, so it's all something the object has. All right, going to do another example. Okay, now this is still in the primate class. I'm going to create a bird. Well, first of all, I'm going to create a class feathers. Okay, so what is this? Every bird has feathers. So every bird will have an array of feathers. Now, technically, I suppose you should say feather, shouldn't you? Because you're creating a feather. You're not creating feathers. Now, that's it. Huh? You can, but like if you were going to create an array of feathers inside here, you'd call it feathers. But you're creating one feather, so technically you should call it feather. Yeah? Okay. So I'm not going to put anything in there. So what I'm going to put in after it is, so class bird. Now, so put in here a bird has feathers. In this case, an array of thousands of feathers. Again, this is has a relationship. Okay, so I am going to create a private variable and I'm going to call it feathers. All right, and it's going to be an array of feathers. Oops, sorry. It should be private feather. It's an array of feathers, and I'm going to call it feathers. Okay, so I'm going to have a constructor. A bird. Now, so what I'm going to do is the amount of feathers is going to vary from bird to bird. Okay, so what does this do? This sets the amount of feathers. It's between 1 and 100,000. Okay? So every bird is going to have between 1 and 100,000 feathers. All right? So how we do that? So I have a variable called int num feathers is equal to. Now, we're going to be using this a fair bit as we're going along. Right? So if I go math dot random, that's going to give us a number between, bring up my pen. What if it disappeared again? I don't. Why are you going hiding, Noel? Are you shy? Alright, so we're going to be using this a lot, right? So we have to get familiar with it. Now, math.random, what that does is, okay, so math is a class, random is a static method that returns a random number between 0 and 1. Now, it produces a double, yeah? So it produces a number between 0 and 1. Now, I think it's to 6 decimal places as far as I can remember. All right? So, how many numbers is there between 0 and 1? Infinite. Okay? But math.random, as far as I know, it does it to 6 decimal places. All right? So, if, let me just see what it actually does produce. So, give me a second. So, I'll just put this into main and see what's produced. Count it out for a minute. So, I forget what's actually produced. So, let's see. Now, so this produces, so it produces 2, Jesus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's the 17 decimal places, which is a pretty big number. That's billions would be 9, trillions would be 12. I don't know what goes beyond trillion. What's the next one? Does anyone know? Billion, billion, trillion. What's after trillion? Ablashed. I don't know. Okay. Anyway, so that produces a number between 0 and 1 to 70 decimal places, which is even more than a trillion. Okay. Now, that produces that number, right? So, let's say if we want to produce a number between 1 and 10, okay? All we have to do is multiply this by 10, and it'll give us 4.8, okay? I'll run it again. It should give a different number the second time. Run it again. So multiply that number by 10 will give us 1.5. Yeah? Okay. Multiply it by 100, it'll give us 15. Multiply it by 1,000, it'll give us 152. Point blah 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 blah. Yes? Okay. So if you want to get a number, so first of all, if I want to change that to an int, all right, what we need to do is we need to cast it to be of type int, which we can do. All right. So if that at this moment in time, if you go int math.random, what number will this produce? 0. Okay, because all you're casting to an int, it just chops off that part. That's what it does. Okay. Right. So I want to get a number between, let's say if I want to get a number between 1 and 100, between 0 and 100. Okay? What you do is you multiply it by 100. That is going to get you 50. Do you understand that? Yeah? So that's going to give you 50. So if I go, it's going to give you multiply by 1,000, it's going to give you 152. If I multiply by 10,000, oops, if I multiply 10,000, it's going to give 1,523. If I multiply by 100,000, it's going to give us 15,230. Okay, so by doing this, so int feathers is equal to int, that's right, yep. So int math random multiplied by 1,000. Now it does this part first. Okay, so it multiplies math.random by 1,000, which will give us 15230.467. Okay, so then it casts that to be an int, it lops off that guy, and you get 15,230. Yeah. No, no, no. You can't fit a double inside an int. That's true, but you can cast it because it still contains the right information. Okay, you can cast. Yeah, you can. Okay. So now, just when you write numbers like 100,000, we normally write them like this. Now you put in the comma so you don't have to go counting the numbers, the zeros. Okay, you can see straight away that that's 100,000, and you can see straight away that that's a million. Okay, every three numbers you put in a comma. You can't put in commas in here. If I put commas in here, what's wrong with that? When I put in a comma, what does Java think that is? What does Java see? I'm getting an error. Why? It thinks that it's two numbers. Anywhere you put in commas for lists of anything. Okay, so it thinks that you have a number here, 100, and you have another number here, 0. All right. So instead of putting in commas, what you can put in is an underscore. That makes your numbers easier to read. All right. It's just a handy little thing. So you can see that that's 100,000. You can see that this is a million. Okay. So we're not going to be using millions. We just have 100,000. So this sets the amount of feathers to be between 1 and 100,000. I'm just going to print it out. So SYSO, this bird has num feathers plus feathers, and then we create an array. So and we assign it to feathers. Feathers is equal to new feathers should be feather num feathers. Okay, So if we have 15,000, if this number is 15,000, then this creates an array of 15,000 feathers. Yes? Okay. So this creates an array of the amount of feathers we have got from the above calculation. A number between 0 and 100,000. No, it doesn't. It doesn't have anything. Okay, because all you're doing is you're creating an array of feathers. All right. So this is class feather. There's nothing in it. So this is just an array of feathers. There's no int inside it. This is just. Yep. Int num feathers here. Line 71. No, so because feathers is an array. See it up here? Okay. So this is our array of feathers. Okay. Which holds all the feathers of the bird. Okay. This is an array of feathers which holds all the feathers of the bird. Now, that is a classic as well, has a relationship. All right. So if we go back to examples, I'm going to create a, so bird, I'll just say bird is in primate 5. Okay. All birds have feathers, which is as a relationship. Okay. So I go bird Tweety is equal to new bird, and then all horses have tails. We go Shetland Shergar is equal to new Shetland. Okay, so they are two has-a relationships. Now, we've only got 2 more of these to do. I know they're boring, but we just have to go through them. So penguin, right? So I'm going to go static void ex4. So just give me a minute. So I'm going to put in here for static ex4. This is SYSO object composition. Okay, so what is object composition? Object composition is the process of constructing classes using references to other classes. Okay, see penguin class. penguin class. It can be an alternative to inheritance. So rather than you inheriting from a superclass, what you're doing is you're creating an object from other objects. All right? Or it can be a combination of both. All right? It can be an alternative to inheritance, or it can complement inheritance. And both techniques do have their place in proper software development. Okay, so we're going to go to penguin class. Now, so penguin. Now, the little wings they have, we're going to call them flappers. Okay, so we're going to have a separate class called, or flippers, sorry. Class flippers. Okay. And it has one method called public void flap. I'm just going to say flapping my flippers to swim. So I don't know if they do actually, but I'm going to say they do. We're going to say that with feet as well. So what does he do with web feet? Public void kick. And we're going to say kicking feet to swim. So rather than inherit from a base penguin class, we're going to have a class here that's made up of other objects. Okay, so it's a class that's made purely up of other objects. Now, usually a class is going to be a combination of all things. It's going to have some object composition in it. It could have some inheritance in it. It could have has-our relationships. It could have is-our relationships, all those sort of things. So a class can be all of these things. Do we understand that? It doesn't have to be exclusively one of them. It can be a bit of everything. All right? So, here we go. Private flippers. My flippers. Private webbed feet. My webbed feet. And there's nothing to, so penguin constructor. And we go my Of course, he'd have two of them, wouldn't he? He wouldn't have just one. Yes? He'd have two flippers, he'd have 2 feet. So, ideally, we would have to have that guy. Okay? Because it's got 2 of them. Alright? So, a penguin has 2 flippers. A penguin has 2 webbed feet. Now, do we really need to do this? We don't have to, I'm just showing you. We can. Okay? That's 2 webbed feet. So, we go is equal to, this is how we do it, I nearly forget, so I have to go new flippers, and I go new flippers, new okay, that's wrong. How do I my flippers? Second. So do I put the square? Can anyone remember how to do this? I forget how to do it. Ah, that's the right way. Okay. So my flippers is equal to new flippers array, and it's going to be an array of size 2 with 2 flippers inside it. Yes? Yeah? So this is an array of 2 flippers. Okay? We're going to have an array of 2 web feet. BBED, FBT, square bracket, oops, new webbed feet, new webbed feet, uh, uh, okay. So rather than inherit from a base class that's got all these things, whatever, we're just creating a class purely out of other objects of a class. Now, that's the last one. So this is an array of 2 flippers, right? So there's what's to say about it. This is a class, is an object, it's a class that is made purely out of other objects. So this class is made purely out of object composition. Nothing more complicated than that. Is everyone okay with that? Yeah? Rather than inheriting it from some class, you just have a class that's made up of other objects. Now, a class can have all of these things, can have object composition, can have is-our relationship, can have has-our relationships. Sorry? Well, then it wouldn't. Well, yeah, then it wouldn't be a class made of purely object composition. Okay, but no class is going to be made purely out of objects. All right. Why am I getting a red mark there? Class flipper. Okay. Right, they're all inside class penguin. Bollocks. Now we're okay. Okay. As before, always mark where your classes finish. Okay. In the penguin class, I didn't there and I put 1 inside 1. And of Web3 class. And just to simply create a penguin, per se is equal to new penguin. Now, the last one we're going to cover is Java B. Okay, now Great. So penguin per se is equal to new penguin. Now, so static void ex5. So this is Java Bean. So I want you to go to the Java Bean class. Now, this is just a standard for creating classes. So Java Bean is a standard for creating classes. Okay, that store data and adhere to the principles of encapsulation. So encapsulation is all about sealing in your class. Okay, that's what encapsulation really is about. Sealing in your class, and the internals can't be mucked around with. So I would say encapsulation is making most of your variable, making most of your internals private, as many as you can. Right? To make, I'd boil down encapsulation to making the internals of your class as much as possible make all your different members private. Right? Now you have to be careful. Obviously, if all your constructors are private, then you can't create an object outside of the class. Do you understand that? If I went in here and created all the constructors as private, that means I can't create a Java Bean object outside of the class. Yes? Okay? Now, there is still a way to create objects, which we'll be doing actually this evening. There is a way to create objects, even if all your constructors are private. All right? Now, now Java Bean, that's just the name of the standard. Right? This class could be called anything. Dog, cat, sheep, whatever. All right? So Java Bean isn't a particular structure, it's just a standard. Okay? Right. Now, so what are the rules are as follows. Properties are private. So the variables are private. So hello? Hello? Not too bad. Who's this? How are you, Kieran? Tis Noel, Kieran. Wrong number again. I sent you another number, Kieran. All right, Kieran. Look. Yeah, all right, so Kieran. Look at that. Yeah, I'm gone blurry. Clean me. Still blurry. Perfect. Right. So properties are private. So getters for properties and getters for non-Boolean properties begin with the word get. Okay, so getter for Boolean properties may begin with is or get. Now usually is. Okay, clearly show that you're getting a Boolean property. You should begin them with the word is, but you can begin them with get. Now you can do anything. There's nothing enforced here. This is just a standard. Okay. So setter methods begin with set. Okay. So the method name for a getter or setter must have a prefix of set, get, is, followed by the first letter of property in uppercase followed by the first letter of the property in uppercase and the rest of the property name in lowercase. So we've been doing this all along, all right? So this is just a standard that is used widely, software development. Eclipse does most of this naturally for you. Now, by the way, you can change all these settings in Eclipse. There's literally thousands of different settings in Eclipse, and you can get it to do all sorts of things automatically for you. All right. I've never gone into them because Eclipse can be a pain in the arse to use at times. Right? It's not forgiving at all, as you probably know by now. All right. So these are the default settings. So I'm just going to do a class that follows the Java Bean principle. Okay. So make all your variables. So all properties private. So I go private Boolean playing, private int ID, private double weight, private Boolean running. Now, so I'm only going to do getters, right? Now I'm not going to get Eclipse to do them. I'm going to do them ourselves. All right. So we have public Boolean. Obviously, the getter should be public as well. All right. So public Boolean is play. Okay. So playing is a Boolean. So we can use get or is. I would use is. So public Boolean is playing. Return playing. Public double get weight. So GET capital W. Return weight. Now, also if you're following the Java Bean standard, you can also go public Boolean get running. Okay, return running. All right, so this is a Boolean. Okay, all right, I should change this to capital B. Now, sorry. Oh, you could use get claim, yeah, yeah, yeah. Well, yeah, but it's no harm to differentiate that this is returning a Boolean because there's only two values. Okay, as far as I can remember with Eclipse, if you do it all automatically, it will say is playing. Okay, so now get running. Running is a Boolean wrapper object. Okay, so now this is probably an exam question. Okay, it'll be a fairly simple exam question, but this is an exam question. This is a Boolean wrapper object. So the correct getter is get running. Okay, so this is a Boolean, so it is get not is. Oh, sorry, this is a Boolean wrapper object. So it is get, not is. All right. So again, that's an exam question. Fairly certain. It's a simple exam question, but it's an exam question that'll catch out a lot of people. Right? But it won't catch out you because you know it now. Okay? So there we have. That looks like another sure as shit exam question. So that's all there is to design principles. Right? It's just names of things you do in software develop or when you're developing your software. All right. All classes are going to have is a relationship going on. All classes are going to have has a relationship going on. All classes are going to have object composition going on. All classes are going to have Java beans going on. Well, should anyway. All classes are going to have, what else is there? Is a, has a, and invariance as well. Okay? Invariance is something that's true, no matter what. Okay? So invariant, something that holds true, so an age always has to be greater than 0. Is our relationship some sort of inheritance relationship going on, usually? So a employee is an object. An astronaut is an astronaut. An astronaut is an employee. An astronaut is an object. Astronaut implements movement. An astronaut is a movement. That's the way you say it. Has a, it's something it has. A bird has feathers. A fish has fins. A something you have. Okay. So the ones Java beans make things private, have getters and setters. Okay. Object composition. You're making your objects out of other objects. So an object that got pure object composition in it, there's nothing in it but other objects. All right. Any questions on that? They're just 5 design principles. They're not anything new there. They're just principles to adhere to. Okay, so that is that section finished. Nothing difficult about that at all. I'm going to export the code. So this is 2.4 understanding design principles. So finish that, overwrite it. I'm going to stop the video.